Welcome to another episode of No Two Forks Given. For the last 5 episodes, I've been assembling this Vyrus 986. For this episode, I'll be discussing what it's like to buy one of these bikes, the options available, things that are unique compared to a normal sports bike, and finally, what is it like to pilot one of these things on the racetrack. So let us begin. The Vyrus 986 is truly a rare exotic motorcycle, with production numbers capped to 50 units total. Purchasing a Vyrus motorcycle is a very unique experience. Instead of wanting what's been built, it's about building what you want. Some owners would visit a factory to meet a handful of craftsmen that tailors the bike to exactly what the owner wants. The factory is located along the east coast of beautiful Italy, just down the street from the Bimota headquarters. Purchasing a Vyrus and visiting both factories would be quite a grand tour. Once at the factory, the future owners would go over all the options available, at additional costs of course. Everything from upgrading the Brembo calipers or master cylinders to the engine hop-up kits from Honda Racing Core, and for a fairly hefty figure, carbon fiber wheels by Rotobox. The frame can be anodized in various colors, notably I've seen a magnesium-like color, black, and of course clear. This isn't the typical 6061 aluminum, it's the 7000 series aluminum known as Ergo, which is stronger and lighter than the 6000 series. The foot pegs, supports, linkages, and levers are also made from Ergo. This frame is made specifically for the Honda CPR 600RR engine. You can see here the oil sight glass is still visible and not blocked by any structural elements. The same applies to the clutch cover as well. All the clutch cover bolts are easily accessible despite the engine being cradled by the frame from below. For the right engine cover, you should change this particular bolt from a socket to an Allen bolt. The original socket bolt will not easily clear the torque rod, so for those of you sourcing your own engine, do not forget to replace this one, as you might have to disassemble the majority of 96 just to service the right side of the engine. Additionally, the frame does block the water pump. In the previous episode, I preemptively replaced the water pump while the engine was out. Like some race bikes, Vyrus removed the thermostat and replaced the thermostat return passage with a bolt to block it off. The rear swing arm is mounted through these plates. I believe this design allows you to custom make different plates to adjust the height of your swing arm pivot for different chassis geometry and therefore handling. Another option are the front swing arm protectors. These are 3D printed, pretty rigid, and are super easy to install and replace should the unfortunate tip over happen. The standard shocks for the 986 are made by YSS, though from previous episodes you all have seen me use the Ohlins TTX 36 instead. While these shocks are off the shelf per se, Bimota Spirit worked with Andreani Group to refine the Ohlins specifically for the 96 at the racetrack. For folks who might not have heard of this company, they are the Ohlins suppliers for World Superbike and Supersport. A street lighting kit is also available. I've seen earlier generations use headlights that require an opening in the windscreen. Newer lights seem to be LEDs embedded within the windscreen for a cleaner look. The upper fairing bolts also double as your mirror mounts, and of course the tail would have a license plate holder and tail light, something this bike does not have, thus a cleaner look with no holes to plug up. For the exhaust, you can select a side or center exhaust system. The side one will follow along the swing arm, just like in many of the Moto2 race bikes when they use the same Honda engine. I personally prefer the Vyrus exhaust that goes through the center of the swing arm and out under the tail for a more tucked-in symmetrical look. For those wanting to ride their 986 on the street, your kickstand will mount with these 2 threaded holes. Since this is a dedicated track bike, the kickstand was left off. Of course, the best option, in my humble opinion, is the kit version. Vyrus provide pages of torque values for the major assemblies, all in Italian. If you are an engineer, these diagrams are works of art. I'm likely going to scale it up and hang these on the wall of my shop. If you're looking for a step-by-step instruction, like a Lego set, this is not the kit for you. Both Bimota Spirit and Vyrus were quick to answer any questions I had, and I probably only sent them a single handful of questions, mostly on very minor things. If you built a few bikes, have some common sense, and the right tools for the right job, then building the 96 is actually a very relaxing and wonderful unique experience. And while these pages are all in Italian, the beauty of quality engineering is that it speaks for itself. Plus, it's not hard to go online and translate the words and learn some Italian as you learn to become your own mechanic for your 986. For the kit option, one thing you will need is an engine stand. Vyrus will provide you the dimensions of the stand so that the engine oil sump will sit perfectly in the stand slots. Keen-eye viewers might have noticed that indeed my engine stand is made from a solid chunk of aluminum, as opposed to a more sensible 4-piece bolted design. However, I assure you this was not lazy engineering from me. When sourcing machine shops using mostly their automated online quoting system, it turns out that the price between making the stand as 4 pieces was just slightly cheaper than making it as a single billet, so I opted for a single piece for slightly less risk of mismatched bore holes and improper machining. And just in case you're wondering, this was only made using the 6000 series aluminum, not Ergo. That would have actually been cost prohibitive.
Some of the earlier prototype 96 pictures showed a side radiator of sorts located right here. So you can see the lower one is just right here right now, but the early ones had a side one. I suspect this side one has to do with something like cooling down the oil, because the oil filter is located right behind these pipes. So it makes a lot of sense just to keep it all within the same area.
You can tell the difference between an earlier and later Gen 986 by the upper radiator. The later gens used a wider radiator, thus the fairings are slightly wider too. The stock 986 reuses the analog dash from the Honda CBR 600. You can have Vyrus integrated modern dash and data logger if you want to go digital. I upgraded the dash myself only to learn how involved the integration is so I can upgrade other bikes as well in the future. Right behind the steering is a hatch for street bikes with a keyed ignition. If you have a good 3D printer, I'm sure you can also create a holder for small item storage. A regular front fork stand will obviously not work for the 986. You'll need a second rear stand to lift the front wheel off. When lifting the front wheel up, be sure to not pinch the brake lines. There's ample space to avoid damage, but it's not something you want to question when you're over 120 miles per hour.
The steering works like this. Handlebar's up here, and it's connected to two dog bone linkages right here that you can see. And you can steer just like a normal motorcycle. There's definitely questions about whether there's slack in the steering and resulting in no feel, but without using multiple linkages and just two dog bones here connected to the steering head, it's pretty much it's a one for one. There's no slack whatsoever that I can notice and feel anyway.
Here's a close-up of the hub center steering system. In the middle is an almost vertical kingpin that the hub pivots about. The kingpin is attached to a horizontal fixed axle that connects it to the swing arm. I was told these hubs are the same across all the Bimota and Vyrus motorcycles. Additionally, with such large bearings, none have really needed service, though that may be because many of these are sitting as collector pieces. If you're curious about the hub system itself, on the official Bimota channel, there's a video on servicing the hub for the Tessie H2, all in Italian of course, and yes, you'll need to buy or make your own special tools to service it. This is a close-up view of the two linkages connected to the steering handlebars. If you look through the air intake nose cone, you'll see how the top linkage is attached to the handlebars. In total, these two linkages have 3 points of articulation to account for the up and down travel of the front wheel.
One of the unique features of the early prototype 96 was a hydraulic steering instead of a linkage steering. So located right here, if you look at some of the early pictures, was like a piston, and it connected to the front wheel assembly. By pushing and pulling, it would turn and steer the motorcycle. So on the other side of the cylinder would connect all the way up to like a master cylinder located up in the center of the motorcycle, and then that's connected to the handlebars for that push-pull action. It's unknown why they got rid of it and instead reverted back to the direct linkage type steering. So this brake caliper and this assembly and this fender are all basically one unit. If I were to remove this bolt here, this whole unit would pivot. So what happens when you brake is that the forces here are transmitted ultimately through a spline right here to this point and this rod, and basically the force of pulling from the braking is transmitted to the chassis as opposed to the suspension that causes it usually to dive.
Adjusting the front shock requires squeezing your hand behind the linkages. Depending on which side you had your shock adjusters mounted, you will have to turn the steering to make room for your hand. Needless to say, the space is tight and you're likely to burn yourself with a hot engine. More on why this isn't a huge problem later. Perhaps in the future I can make some remote adjuster that's accessible via the hatch behind the steering bars. Here's how I oriented the shock and the dials I'm turning that are hidden behind the radiator. Once I finished assembling the 986, immediately I noticed just how small the 986 is. It's actually the second shortest bike in my shop, the shortest being a Moto 3 Moriwaki. Lining the Vyrus up with a few other bikes in the shop, you will get an idea of just how short the overall length is. From the left to the right is the Moto 3 Moriwaki, the Vyrus, a Ninja 250, and a Kramer 690. I looked up the wheelbases for each bike here. Very few track bikes will have a shorter wheelbase than a Moriwaki at 1,230mm. The Vyrus is at 1,325, and the Ninja and the Kramer are both at 1,400mm. The Honda CBR 600R that this Vyrus borrows its engine from has a wheelbase of 1,370mm, so longer than the Vyrus but shorter than the Ninja and Kramer. Immediately on my first ride on the 986, it was noticeable just how good and stable the brakes are at any speed. Here's a simple demonstration at walking speed. Note how the chassis didn't dive when I slammed on the brakes. And compare that with the fork dive on the Kramer. Without the usual fork dive, it feels extremely planted to a point where I think doing a stoppie will be a challenge. There are drawbacks, however. Swapping the front wheel on a hub-centered steering system is more involved than a fork motorcycle.
The first thing is to remove bolt right here that connects the linkages to the front wheel assembly. Afterwards, to take the wheel off, you'll have to disconnect this arm here, followed by this bolt on both sides. That will release the whole front wheel assembly. To remove the tire itself, then you have to remove this kind of structural front fender. 3 bolts here on this side, and then you have to remove the brake caliper mount. A couple bolts here, and obviously the brake caliper here. Just to be able to remove all these assemblies and clear the tire away. So in total, there's at least on this side 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's another 10 on the other side, so that's 20 and 21 at least before you can clear to change the tire on the front wheel here. Compared to a fork motorcycle, definitely a lot more bolts.
The Kramer here is typical for a fork motorcycle. To remove the front wheel, you have the 2 pinch bolts, the axle itself, the front fender, and for certain models, the brake calipers. That's a total of 11 bolts. You can, however, reduce the number of bolts to swap out the Vyrus wheels by having an entire front wheel assembly ready for swap. So then you have to remove the pinch bolt, the axle itself, and the steering linkage, and the pinch and axle on the other side for a total of 5. But this would involve purchasing an entire assembly to include the brake calipers with a quick disconnect hose. If you don't want to swap out the calipers, then that's an additional 4 bolts, so 9 total. And yes, you'll need a special tool to balance the wheel. To prevent the hub from pivoting about as you balance the wheel, you'll need these adapters. Needless to say, your local friendly tire guy is unlikely to have these. The rear wheel of the 986 is pretty typical for removal. For track riding, Vyrus installed a 190/60 tire. The street 986 uses a 180/55. I originally thought my chain was close to rubbing the wheel, but after adjusting my alignment, the tire had ample clearance. That said, I noticed the chain side had no balls of rubber unlike the right side of the tire. It's likely because I was on clockwise racetrack, so majority right turns. The carbon fiber monocoque, while it is a little oddly shaped, is actually quite functional. As a short rider, getting onto the cockpit was no issue. The cockpit has ample room to slide both to the front and rear of the seat. Tucking in is pretty typical as well. When leaning over, the shape of the monocoque allows you to rest your forearm on the tank so that you can stay light on the handlebar inputs. I really like how the shape serves both form and function. Here's where I felt my forearm can rest comfortably on the monocoque tank. When leaning over, the knee slots nicely into the shape of the monocoque as well. Otherwise, all the controls are pretty typical with small adjustments available so you can fine-tune the controls to exactly where you naturally want. As a short rider, the tail cone drooping down makes it much easier for my leg to swing over without hitting it, especially while wearing a racing suit. That said, I do have a piece of clear paint protection film on the tail, just in case. I still have to make sure I don't hit my GPS antenna though. At 332 pounds or 150 kilograms without fuel, the Vyrus is easy to balance on my tiptoes or with just my left foot on the ground and my right foot on the rear brake. Sitting on a 986, it was noticeable just how softly sprung the shocks are. Unlike fork motorcycles, by separating the braking forces from suspension duties, the Vyrus does not need to run stiffer springs. The Kramer, on the other hand, has a much stiffer suspension setup. For reference, the Kramer's curb weight is 276 pounds or 125 kilograms. This is about a 56 pounds or 25 kilograms difference. While a fair comparison test with the Vyrus would be with a Honda Moto2 600 bike by Suter, Kalex, or Moriwaki, I unfortunately do not have access to any of those. However, the Kramer isn't too far off as a comparison point. They are both thoroughbreds racing motorcycles, and in fact, both the Kramer and Vyrus are running the same 120/70 size front tire from the same manufacturer and model. The Kramer, however, runs a smaller 180/55 rear, which if you recall is the same size for the Street 986. Engine-wise, the Kramer is about 80 horsepower with 75 newton meters of torque, while the Vyrus is about 119 horsepower with 64 newton meters of torque. To recap, the single-cylinder Kramer is lighter, lower horsepower, higher torque, and longer wheelbase. The inline-4 Vyrus is heavier, higher horsepower, lower torque, and a shorter wheelbase. Like the Vyrus, the Kramer also has a data logger dash. By pulling data out from both bikes, I can perform a more objective numerical comparison of both bikes on the same racetrack. Here's a sample of what the data looks like from the Vyrus. When I first started the software up, it was all in Italian, so once again you need to learn some Italian to switch to English. This is the data from the Kramer. Both loggers record typical data points like speed, location, time, and position. The two more interesting data points are longitudinal and latitudinal acceleration. In other words, how many G's I'm braking and accelerating, and how many G's I'm cornering respectively. Since these two data loggers are not compatible with each other, I exported the data out and wrote some scripts to plot and compare the Vyrus and Kramer data. I had to think a bit on what's fair to compare since, like most of you, I have had more experience on a fork motorcycle than a hub-center steering bike. I also have more riding time on the Kramer than the Vyrus, and I have been tuning the suspension on the Kramer and adjusting its final drive ratio to lower my lap times. Ultimately, for this comparison, I settled on this. I looked at data for my first day out on the racetrack when I was first new to these bikes. I looked at the last two sessions where I spent an entire day learning the bike, and now I'm trying to put it all together. And surprisingly, I found my lap times were basically within 1 second of each other on day one, meaning both bikes are probably much more capable than me. However, my local track is pretty short, and my current final drive ratio on the Vyrus isn't ideal for it. I suspect if I change the rear sprocket, I can probably get the Vyrus to have a faster lap time. The data does show I can brake and accelerate harder on the Vyrus, and interestingly, I recorded a higher turning G-force on the Vyrus a few times, though I was cornering longer on the Kramer in general. This makes sense because I was picking more wider, higher corner speed lines on the Kramer. On the Vyrus, I was picking more point and shoot, probably because of just how good and stable the brakes are. Flicking the Vyrus from side to side is also unique. With no brake dive and forks that changes your wheelbase substantially, I felt it was easier to corner. You don't have to manage how hard you're braking to create a shorter wheelbase to turn at speed. On track or over really bumpy pit lanes on my local track, a lot of the bumps and dips were also noticeably muted on the Vyrus. The chassis never really got upset at the bumps and dips. You know it's there, but it didn't really cause a steering shudder or harshness like it would do on a fork motorcycle. It could just be Vyrus did their homework and gave me a perfectly set up bike. You certainly would expect it for the price, and the shocks being fine-tuned by a top-tier tuning shop. At my amateur skill level, I did not feel there was much need to adjust the front shock, thus the risk of burning your hand over the radiator just to tune the front shock isn't an issue for me. I do want to point out that the Kramer's WP forks and shocks are phenomenal. They are top of the line, and the whole Kramer package offers an immense amount of adjustments from your typical rebound, preload, and compression settings, and even fork offset adjustments, all with pre-computed rake angles, trail, and wheelbase data. Just like the Vyrus, these suspension components are much more capable than what I can achieve, but I can certainly feel there is a difference between forks and hub-center steering. Whether one is faster or not, I think only a professional racer can tell after some proper setup. But as an ordinary rider on two extraordinary bikes, I think my conclusion is this. Hub-center steering is like flying through laminar air, while forks is like flying through turbulence. You can actually be faster in one or the other, but laminar air is certainly a much smoother ride. The price of entry to the world of Vyrus motorcycles, or most hub-center steering motorcycles for that matter, is very high. For the price of the 96, you can purchase 3 or 4 superbikes, and they will absolutely be faster with its more than 200 horsepower engine and electronic suspensions. If you like more of the same, those superbikes are absolutely a good deal compared to the 986. But if you want something different, both in terms of riding and building, there's not really much out there that offers you something this unique. It certainly is a modern era Grand Tour experience. I'd like to take this moment to thank all the viewers and subscribers. I recorded my build mainly just so I can look back at what I did for future references. Halfway through, I decided to make it into a YouTube series, and didn't expect it to achieve a fraction of this many views. I tried to read as many comments as I can, and there are a few that really struck out to me. The first one is from Speakeasy2, who pointed out I didn't stake an inner clutch hub nut. This is a viewer whose attention to detail is up there, and I appreciate having a second set of eyes on my work. The reason why it wasn't staked was because I used Loctite instead, but it's still great that viewers are watching with sharp eyes. I think most of us know, especially those of us who do our own wrenching, just how little it takes for things to go wrong on a motorcycle. The next comment from The Indian mentioned the Moto Enos Ducati. I've never heard of it, and it's cool to see other non-fork motorcycle designs out there. Dimitris the Greek 411 also mentioned a motorcycle called Leafes Fanasis, a non-fork motorcycle from Greece over 30 years ago. Not a whole lot of information on it, but certainly very fascinating from the few pictures you can see of it online. And finally, Mac X mentioned the auto-mocking Tonichi torque wrenches. I think by now folks know I'm all about using proper torques, always. Yes, I have seen those Honda bolts marked perfectly and exactly on the same spot. I never realized it's because there's a special torque wrench that does it automatically. I've always thought it was a person with perfect penmanship. Thanks for the info. So what now for the channel? Between my work and life outside of motorcycles, there's not a whole lot of time in the day to accomplish everything. But this is my next big project. This is a Honda VFR 400R NC30. When I first purchased this crash bike, the engine was only running on half its 4 cylinders. Since then I've overhauled it, sending parts out to machine shops and sourcing other parts from around the world. It is now a 428 cubic centimeter engine, powered by pistons made by none other than Cosworth, and there are a plethora of other modern upgrades both inbound and planned for it. If folks would like another build and review series on the Honda VFR 400, please feel free to like and subscribe to this channel. It's a signal for me that it's worth my time to film and edit as opposed to just build. Otherwise, thanks for watching.